This lesson is on comparing numbers with inequalities. So when we're comparing two numbers with inequalities, what we're doing is finding out where they are in relationship to each other on the number line. The further you go to the left on the number line, the more negative or the lesser the value. The further you go to the right on the number line, the more positive or greater the value. So for our first example here, I have A at -6 and I have B over here at +4. Now A is to the left of B, and so we can say that A is less than B. One other thing to point out, a little Pac-Man knowledge here, is if A is less than B, notice if this were Pac-Man, Pac-Man would be open to the larger value because Pac-Man always wants whatever the larger value is. For our second example, we have B over here at -8, and we have A over here at +2. Now B is to the left, so I could write B is less than A, and that would certainly be a correct way to write them. If I want to write A first, I'm saying that A is greater than B. So A is greater than B. Again, notice the mouth is open to the larger of the two values. One way to help you remember which one's greater than which one's less than, if you take the less than sign, I'm going to have to do it backwards for you. So if you take the less than sign and you turn it like this, it turns into an L. So for me, I'm looking at it like this. Since you're backwards, you're looking at it like this. So if you put up your left hand, make a less than sign, that turns into an L. Here are some of the inequality symbols that you will see quite often. Our first is less than, which we just talked about, and greater, which we just talked about. Then we have these two that are very similar to those first two. So this is A is less than or equal to, which means A could be the lesser number or it could be equal to. So instead of writing A is less than B or A equals B, this is a way of shoving all of those together. Same thing for A is greater than or equal to B. For instance, if A was greater than B, I couldn't say 4 is greater than 4. That would be wrong. But I could say 4 is greater than or equal to 4 because it's equal to. And then, of course, we've got equal to. We've got not to equal to. That's an equal with a slash through it, not equal to. And then we have approximately equal to. So the little squigglies mean it's not quite. You'll see this quite often. Say I've got, let's see, A is 2/3 and B is 0.67. Well, we know that 2/3 as a decimal is 0.6 repeating. So we could say that A is approximately equal to B, but they're not exact because B would have to be 0.6 repeating. So that's one example. So there are two ways that we can compare numbers fairly easily. The first is to write fractions with a common denominator. So I'm going to look at 2 and 2/3 and 2 and 2/5 and see which one is bigger. And you might know just by looking, but it's important that you understand how to find these values. So if I wanted to write these with a common denominator, I'm going to look at the 3 and the 5. And you can kind of do this in a couple of different ways. One way is to write out all of the multiples of 3. So 3, 6, 9, 12, 15, 18, etc. And then do the same thing with 5. 5, 10, 15, 20. And what I would be looking for there is that number that they both go into, which is 15. Then I'm going to make my fractions have a common denominator. So in order to turn 3 into 15, I have to take it times 5. But if I do that to the bottom, then I also have to do that to the top. Okay, so now this turns into 2. Notice I'm not messing with this 2 on the outside. I'm leaving it right there. So 2 and 10/15. And now I have to look at this in terms of 15ths, so they're broken into the same amount of parts. And I would take this times 3, which means I'm going to take the top times 3 as well. So this one turns into 2 and 6/15, and obviously 10/15 is bigger than 6/15, and so my sign is greater than. Now over here, I can also write them as decimals, which is easy if you have a calculator. I'm going to do this without a calculator just to make sure you know how to do it both ways. If I were doing it with a calculator, in my calculator I would just take 2 divided by 3, and then that would give me 6 repeating like we just talked about on the other page, or your calculator might say 0.6666 and then at the end have a 7. And then again on my calculator over here I would do 2 and then I would take 2 divided by 5, which is 0.4. And so those are the two that I'm comparing. Before I actually compare them, let's also look at how we would do this if you don't have a calculator. I would keep this 2 on the outside, so I'm going to leave the 2 alone on both of these examples. But for this one, I would put the 2 on the inside and the 3 on the outside. And say, how many times does 3 go into 2? It doesn't. But does it go into 20? Yes, it goes in 6 times. 6 times 3 is 18. I subtract to get 2. I'm going to bring down another 0. 3 goes into 20 6 times, and we can see that we would just keep repeating the same process over and over, thus the 2.6 repeating. On the other side, I would put the 2 here and the 5 here. And again, 5 does not go into 2, but it goes into 24 times. 4 times 5 is 20, and that's where I would get the 0.4. Either way, I'm looking at 2.6 repeating and 2.4. 2.6 is greater, and so 2 2/3 is greater. So notice I got the same answer both ways, but I found them in 2 different ways. It really doesn't matter which way you choose to do it. You should choose the one that makes most sense to you. Here are a couple more for us to try. Over here I've got 3.3 and then I've got 3.3 repeating. So when I have a number that's very, very close like this one is 3.3, and if I needed to add a number it would be a 0. And over here I've got 3.3, and these 3's go on forever and ever and ever and ever. Whoa, forget about that last 3. So here what I'm going to do is I'm going to compare the 3 with the 3, and those are the same. And I'm going to pair the 3 with the 3, and those are the same. And then I'm going to compare the 0 with the 3, and here's where I can see a difference. This 3 is bigger than this 0, and so my answer is less than. 3.3 is less than 3.3 repeating. Here, 2 2/5. Again, we're going to turn 2/5 into a decimal. So this turns into 2.4. On this side, I have 2.4. Obviously, those two things are equal, so we're just going to put an equal sign. And then over here, I've got 1.85. This is a decimal. So when you have them that are both decimals or both fractions, you can kind of choose which one to use. If you have one of each, easiest thing to do is to go ahead and use decimals. So I'm going to take 6 divided by 7, and I'm going to get 0.85, 714, etc. Over here it's 0.85 and then obviously a 0, as many zeros as I would need. So again, I'm going to go back to comparing the 1 with the 1. Those are the same. 8s and 8s, those are the same. 5 and 5, those are the same. 0 and 7, the 7 is bigger. So it's going to look like this. So I've got a less than, an equal to, and another less than. As always, when you get to the blue titled questions, these are questions for you to try. So try all 3 of these on your own, then press play and see how you did. For our first question here, I've got 5.7. And on the other side, I have 5 and 5/6. So in order to compare these properly, I would take 5 divided by 6. And 5 divided by 6 gives you 0.83. And the 3 is repeating. And again, comparing the 5s, those are both just 5. This side I've got a 7, this side I've got an 8, the 8's bigger. So I'm going open to the bigger value, so this is 5.7 is less than 5 and 5/6. For our next one, 4/7, again you're going to take 4 divided by 7 in your calculator. This gives me a decimal of 0.5714. Over here, 3/5, if you take 3 divided by 5, you get 0.6, and so 0.6 is bigger than 0.5, so it's a less than. This one is a little bit tricky because now I'm dealing with negatives. So this is negative 7.22, and this is negative 7.2222, etc. So again, this would be zeros if I needed them. Now, if I were looking at this without those equal signs, I would say that this one is bigger because I compare the 7s, and they're the same. And I compare the first set of 2s, and those are the same. and the second set of 2's, and those are the same. So now I'm going to compare the 0 and the 2. So if these were positives, I would be looking at the less than sign again. But because now we're looking at negatives, this number is actually more negative. It's further to the left. If I were plotting these on the number line, and this was negative 7.22, and this were negative 7.23, this number would be over here, and this number would be probably about right here. So this one is actually further to the left. So this one is actually less than. So we're going to look at this sign. So this negative 7.22 is greater than negative 7.2, repeating.